Greetings, this is Mr. Garwood with our continuing video series on Calculus 2nd edition by Briggs, Cochran, and Gillette. This video is going to focus on limits of polynomials and how to evaluate them. What I'm going to do is I'm going to start by breaking this up in general. You'll notice here that I'm solving for the limit as x goes to a, so the limit as x goes to any value that's real with the function p of x. I'm going to focus on the limit laws and show you how we break this up using the limit laws. This is theorem 2.3 and this is found in section 2.3 of your text. I'm going to reference these laws in order just as they appear in your X. So I'll refer to law 1 dealing with sums as law 1 and so on. So our first example today, and if you're using the online textbook, this is the same as the example they give for polynomials. And all we're going to do is we're going to look at how can I break this up generally for any value of a so that we can find an easy way of evaluating the limit. So the limit as x goes to a by substitution here is just the limit as x goes to a of the polynomial. And notice I'm putting everything in parentheses saying that I am grouping p of x as all of this function. Now, by law 1, which deals with sums, that just says that the limit of the sum is the same as the sum of the limits. And what that means is I can rewrite this as the limit as x goes to a of 7x cubed plus the limit x goes to a 3x squared plus the limit x goes to a, and we're going to leave this linear term at the end alone. So the limit of the sum is the same as the sum of the limits. Those are exactly the same. And as I said, this is law number 1. From here, I can use law 3, which is the constant multiplication. What that means is that, notice here I've got 7 times x cubed. Well, that's the same as 7 times the limit as x goes to a of x cubed plus 3 times the limit x goes to a x squared. And I'm going to leave this linear term at the end alone. And this was law number 3. Now the last step we're going to take is, because this is a perfect power, I've got x to a power, that's the same as the limit to a power. So I can say that's the limit x goes to a of x all cubed, and similarly 3 times the limit as x goes to a of x all squared, and again we just leave this linear term all by itself, and that is law 6. Now, definitionally, the limit as x goes to a is simply a. Similarly here, and this is just 4a plus 2. So what I have here is this whole limit is 7 a cubed plus 3 a squared plus 4 a plus 2, and I'm going to come back in and fill in these a's. Okay. Well, if we go back to our original thing, that's just 7a cubed, 3a squared, 4a plus 2. Well, that's just p evaluated at a. So here's what I'm really trying to get across. As long as I don't have any domain restrictions, and the polynomials are defined on all real numbers, so I don't have domain restrictions here, all I'm doing when I evaluate the limit is substituting for that value. So here I used all of these crazy limit rules to say that the limit as x goes to a of p of x is just p of a. So if I come back, I'm going to take a new piece of paper on this one because the last one was rather full. If I want to know what's the limit as x goes to 2 of p of x, well, here, that's just p of 2. Or 7 times 2 cubed, 3 times 2 squared, 4 times 2 plus 2. And I could work that out. You could put that in your calculator. So that's 7 times 8, 3 times 4, 8 and 2. 7 times 8 is 56, 12, 8 and 2, 68, 76, 78. Don't quote me on that, just did that in my head. But that's really all it's saying. Is just plug in the value. If I wanted to do another one, I could say the limit x goes to 0 of p of x. Well, that's just p of 0, which is 7 times 0 cubed, 3 times 0 squared, plus 4 times 0, plus 2. Well, 0, 0, 0, 2. This procedure, this theorem gives us a lot of power because it's just plug in the number and go. I hope you found this video useful. Good luck as you continue this course.